Carpe Diem VPN. Seize the network.
Hello everyone, and welcome back to our look at the vManage and the management plane with Cisco SD-WAN. This is the third part in our series, and we should be able to wrap up with vManage and management plane in this video. We're going to start by looking at the troubleshooting options available in vManage, and then we'll go on and look at the access control options available in vManage, and that'll wrap it up. So here we are in the vManage, and to do this troubleshooting stuff we're going to have to go into the monitor and then network section, and then from here we just need to drill into the device we're going to do our troubleshooting from. In this case we're just going to pick DC-WAN 1, which is a vEdge. We'll talk about a little bit about what the differences are of it from a troubleshooting perspective between the iOS XE, SD-WAN, and vEdge. So once we drill into the device, we need to go to the section that's called Troubleshooting. And then here you can see all of the different troubleshooting options we have. Now I know in the last video I mentioned that a lot of the log stuff from vManage is not available, but that's somewhat true and somewhat not true. You can take a look here at debug log, and then from the debug log we actually have the ability to choose some different logs that are available on the WAN edge to look at. So as an example, we can actually look at vsyslog here. We just have to wait for the log to be loaded, but we can actually look at the vsyslog file here in the vManage. But that's, again, more of a troubleshooting thing than really for true logging purposes. So you see here we have the ability to look at the logs in vManage, and this can help us troubleshoot, but for more of a logging perspective, we would probably want to export this to some kind of a syslog server, or somewhere we could use a tool to parse this a little bit better. We have some source options available here in the vsyslog, but it's not quite as robust as like a true Splunk or one of those type of programs where we could really parse out some data from the logging. So let's go back to troubleshooting, and we'll just take a look at ping first. Ping is, well, it works probably about as you would expect. In this case, I'm just going to take the DC-WAN edge. I'm going to just run a quick ping test to a host that's sitting in branch 1. So let me do that first. So here we have to pick what service VPN or underlay or management or whatever VPN we're going to use to ping the device. In this case I'm going to use the service VPN, and when you choose the service VPN it's going to restrict the amount of which interfaces that you can use to ping from, of course, because it has to be in that VRF or VPN. And we'll just run a quick ping test and see what we get here. Alright, well, that's to be expected. You can see that we get a nice little summary of the ping and what the results were, and even a CLI output. So pretty standard. We do have some advanced options with ping. We can say what size, how many we're going to send. Rapid means don't wait for a response. Just don't fragment, of course, is saying don't fragment the packet. So that's basically ping. There's not a lot to it. Let's go back to troubleshooting, and we'll take a look at traceroute next. Now I'll just run that same traceroute, or I'll run a traceroute rather, to that same host. And what's nice about in vManage with the traceroute utility is that, at least for the vEdge, if you run a traceroute, it will actually show you the path through the fabric to the host. So in this case you can see from the DC-WAN edge, we were actually able to see a hop in the underlay because we're coming from the WAN edge, but the next hop is the service VPN and then the host. So obviously if this were a larger network we could see more hops depending on the traffic policies. And if we were using some kind of policy that restricted traffic between certain sites or certain routers, we would be able to visualize that with the traceroute utility as well. So that's the traceroute utility. There's some other stuff here. We can look at something called device bringup. Now device bringup is kind of a checklist, if you will. If a device is joining the fabric, it will go through that checklist. You can see the very first thing is that it has to be authorized by vBond. And that gets back into that zero trust model I was talking about in earlier videos, that whitelist has to exist on vBond saying that this device can join. You can see in this case we have a green check mark, it's in the whitelist. I did not enforce a software image update, but in vManage you can actually set it so that when a device joins the fabric, it has to be upgraded automatically to, say, a golden image. You can see that a router configuration was pushed, meaning that we attached a device template and the config was actually pushed to the device. And then control plane connectivity was established. Now, control plane connectivity, of course, is our DTLS tunnels to the controller infrastructure. And then after that was all done, we got our last green check mark where we established data plane connectivity. And what's cool about this is if it were to have failed, you would actually get a red X mark at any part of the step, and then you'd have a better idea of where in the process the onboarding failed. Some of this would even become clickable to try to get the error messages. Also notice that we have a timestamp for when certain tasks were completed. So that's a really cool little thing that you can use to troubleshoot if you're having trouble onboarding devices to the fabric. Now here we can also do a packet capture, which I'll cover in a minute, but we can do something really cool also called simulate flows. Now this is only available on the vEdge right now because it uses iPerf. And iPerf, of course, is a kind of a simulation utility, and it doesn't exist in iOS XE. But what's really cool about this utility is that we can basically ask the vEdge what if, and then see what kind of forwarding decisions it would make. So especially when we're testing things like application-aware routing, something that's based on an SLA, this would be really useful because the vEdge will report its forwarding decision based on current environment. So let's just run through one of these. We'll say in a situation, maybe we're coming from the source IP in the data center, and let's say the destination IP is that same host. And you have the ability to of course, do some advanced options. So protocol, it's one for ICMP here, but you can choose different protocols. You can choose your source and destination port. You can even choose your DSP markings, and you can visualize it for all paths. So for example, if I were to set a DSP marking of, say, EF, I would put 46 here, and then say that I had an application-aware routing policy that required a certain SLA if the traffic was marked with that DSP value, and then I were to inject latency onto, say, one of the transports, and then simulate this flow. What would happen is that the flows that didn't meet SLA would not show up here in the forwarding decision. But in this case, what I'm just showing you is basically the utility itself. You can see that for the parameters we gave it, the forwarding decision would be pretty easy. So in this case, this is a tunnel formed over both transports. You can see 4 potential paths, and this is default behavior with SD-WAN, where if a transport can build a tunnel over different transports to each other, it will. So there's some policies you can do to either stop that or make that happen. If you don't want certain transports to build tunnels over each other, you can tell it not to. But in this case, it's wide open, and so every transport has tunnels built over it and over other transports. So you can see our forwarding decision is 4 possible tunnels, and it'll do equal cost multipath over those. But again, what's really cool about this is that we get a what if scenario with the vEdge, and it would tell us exactly how it would forward the traffic in this situation. Let's go back to troubleshooting, and let's do a packet capture. The packet capture utility is pretty cool. It allows us to capture actual packets off the box in flight, which is really important because remember, the control packets and the data plane packets are going to be encrypted, so you can't grab this with a tap or anything. You need to do like an embedded packet capture off the box. Now this only works for the vEdge right now, I believe. I think the functionality is coming for the iOS XE SD-WAN router as well. But you can see that we can choose the VPN to capture 4. We can even set up filtering here. In this case, we're just gonna capture everything. So I've got some traffic running. I'll go ahead and start the packet capture, and then we should be able to take a look at it when it fills up here. So you can see we have the ability to stop it ourselves, or we can just wait until it fills up 5 megabyte file. Looks like we've already filled that up, and then we can download the file. So I'll just go ahead and, in this case, I'm just going to open it with Wireshark, so I'll just click OK to open it. But we could also, of course, save it off and to another device. As you can see, what's kind of cool here is that we have a full Wireshark capture, so we can actually see the packets in flight for the VPN. Of course, I'm just sending just an iMix of traffic. You know, some RTP audio, some transactional data, so on and so forth. But I mostly just wanted to show that we have the ability to do packet capture here. And of course, then look at the data. We could do that here, and that's important because, of course, we're encrypting the data otherwise. So there's not really a better way to grab it. So very cool. Actually, now that I think about it, I don't know if this works for iOS XE, so I'd like to take a look at it. And we can go take a look at another device, and we'll see what's grayed out. So let's pick branch 1, which is a CSR, and see what options are grayed out here. Okay, so here we are, and you can see I do not have the ability for packet capture. I can't do simulate flows. I can't look at debug logs because, of course, as I mentioned in the last video, the logging on the CSR and the iOS XE devices is just normal logging. So there's not an actual device log that's produced. I can go through the device bring up. I can look at the control connections. We didn't look at this earlier. We can look at it now. It's actually not that exciting, but I'll go ahead and click on it since it's here. Give it a second to load. This just shows us over which transports we've built, controlled those DTLS connections to the vManage, vSmart. So you can see here, we see we're not using a NAT, and that's just because our lab isn't using a NAT. In the real world, if you're going over internet, it's very likely you might be using a NAT. But what's cool is that you can see it. If it had been a NAT, you could see that, and then see the status of that connectivity, which is again a cool troubleshooting tool. But we can do ping and traceroute. Actually, I think traceroute's broke. Let me try it. At least in this version of vManage, I think it is. I don't think the utility itself is broken. I think just in this version of vManage. And when I go through, let's see, yeah. So when I go through later on, I'll do a video about upgrading the fabric. I'll upgrade the version of vManage, and I think this is probably fixed. But for now, you can see it's in this particular version of vManage it's broke. But yeah, so this is all the troubleshooting options that we have available through vManage. Of course, we have the ultimate troubleshooting tool, which is the ability to just open an SSH terminal to anywhere boxes and run commands. But, you know, I don't really consider that part of troubleshooting per se. That's just device management. So that takes care of troubleshooting. So we covered ping and traceroute. We showed simulate flows. We showed how we would do packet capture. Oh, data stream. I'll cover that in just a second. We covered device bring up as well, but I would like to show you data streams. So let me hop back over to the vManage real quick. Okay, so the packet capture utility is not on by default. We have to turn that on in vManage. So we'll go to administration and settings to turn it on, and I'll just show you how it works. Okay, so it's under this setting in vManage settings called data stream. This is actually disabled by default. In order to turn on the packet capture utility, we have to enable it. So you can see in this case, we have to click enabled, and then we need to choose the host name that we're sending the data stream to. In this case, I'm using the VPN0 address of the vManage so that we can send the packet capture to the vManage so that we can download it. So that's how that feature works. We set the host name of the vManage and what VPN we're going to send it over, and then click save, and then the packet capture utility will work. Let's take a look at the access control options in vManage. We're looking at local access, which means creating usernames and groups and putting them locally on the devices in the vManage itself. Using AAA templates attached to the devices, including the vManage itself. And we also have the ability to do single sign-on with an IDP for access to the vManage, though not the WAN edges. Let's look at the easiest one first, which is configuring local access, both to vManage and to local devices. So under administration and manage users, we see that by default you just have a normal admin account. And then there's several user group accounts which come default. Those user groups are just a basic user which has very few permissions. Then there's the net admin, which of course is the admin user group, which has access to everything. And then there's an operator, which has read access to just about everything, but write access to very few things. That's more like a NOC type of user group. We also have the ability to add user groups. And what's great about the ability to add the user groups is that we can actually very granularly determine what permissions we'll give to the user group. So as an example, if we do one called, say, knock tier 2, we have the ability to, we could check that they can read everything, and then maybe we decide that they only have a small subset of the write ability or ability to push changes. So we will let them manage users? No. We might, however, let them manage policy. We might let them deploy a policy for changes to the fabric. We might give them access to security policy configuration, and so on and so forth. So you see, given this list here, we actually have a pretty good and granular list of the permissions we can grant to a user group. And when we've created the user group, of course, we can go to users, we can add a new user, and give it a name, a username, a password, and most importantly, we can assign it to the user groups that we've created. Now this only gives username access to the vManage and read-write access to the vManage. If we want to do it for devices, we have to deploy a template. So let's take a look at that now. Go to Configuration and Templates. Because this is a feature, think of it like a snippet of code or a particular product feature that we're configuring, it'll use a feature template. So let's add the template. In this case, the only devices we have are a vEdge Cloud and the CSR1000V, of course. Find that in the list here, CSR1000V. And again, notice how when I start checking the boxes, different templates don't overlap. Different features are available on the vEdge versus the iOS XE SD-WAN router. So the overlapping templates are the only thing that will be here. Now this is a problem for us because you'll notice that the iOS XE template list doesn't overlap between the vEdge Cloud and the CSR1000V. So if I uncheck CSR, the AAA template comes back. So that's not an overlapping template. So let's just pick AAA template for a vEdge Cloud this time so we can look at it. Now for device administration of the vEdges or the WAN edges themselves, we have a few options. Let's take a look at the template here. See, we have the ability to decide in what order we're going to authenticate. So you see by default we'll use local, then a radius if it's configured, and finally TAGX. But with the drop down we can of course change the ordering there. Or we could make it device specific if we had some reason to do that. Maybe certain sites or certain types of devices that will use this feature template have a different order that we want them to use. Authentication fallback allows us to fall back to local if one of the configured radius or TAGX fails. Of course, the admin authentication order has to do with the admin account. Disable netconf logs, disable audit logs. We generally would not turn these off, but we have the ability to do it. And then, of course, here's our radius server list, comma separated. From a local perspective, if we wanted to do something similar to what we did just a minute ago in vManage, where we created local user groups and local users, we have the ability to do that. So this, again, will only affect the devices which will end up using this feature template, but we do have the ability to create a user group and then, of course, check the boxes for what we want to allow that user to accomplish on the vEdge. You'll notice that this is a much smaller subset of the permissions that we grant to vManage user. So we'll go ahead and cancel that since we're not going to do this right now. But that was how we would create a local user and assign it to a user group. And then of course we have radius settings. We can set up what's a timeout. We could set up the retransmit count. We could set up the radius server itself, which we would need to do if we're going to use a radius server. And the same with TAGX. So as an example, if we were going to set a TAGX server, here's where we would create the address of the TAGX server, what port we'll use for authentication, the shared secret, what source and VPN, and so on and so forth. Notice also here that we have the ability to mark this as an optional row. What that means is that if for some reason we had some devices that would use this feature template but not use TAGX specifically, we could check that this is optional, and then when it came time to fill in the variables, and this will make more sense once we start deploying templates, when it came time to fill in variables, we could check this box, and then those variables would only be required if we actually clicked in and started entering them. That's what the mark as optional is for. So again, we're not going to do that here. I don't have a AAA server in this lab, but I wanted to show you the options that we have available for device administration. So local, radius, and TACACS. With radius, there's some requirements with radius. So actually, let me scroll up here, move up to the top. I have the product documentation, which we'll look at here. So I feel like specifically for radius, because we have to use specific kind of NAS attributes for radius to do device administration, it's worth covering. Now this, I'll go ahead and link this in the YouTube description, and so you'll have access to this link. But this is the system interface configuration guide for the iOS XE SD-WAN releases and the newest vManage releases as well. So notice here, if we go down to configuring NAS attributes using the CLI, in order to get radius working for device administration, we actually have to create a radius file on the radius server, and it has to include some NAS attributes, some network access server attributes, for it to be used for device administration. So that goes a little bit beyond the scope of what I want to talk about, but it is here in the documentation if you want to read about it, about what's required for using radius specifically. And lastly, let's talk about single sign-on. I'll go ahead and close this. We'll go back to administration and settings, because this is where we set up single sign-on. Now, single sign-on is only useful for vManage. We don't have a single sign-on for the ability to do device administration. So notice here we have identity provider settings. In this case, it's disabled because I don't have an IDP set up. We do have the ability to set up an IDP. So if we do that, we would go to enabled, and then here we would provide the metadata from our IDP, our identity provider. We also have the ability to click and download the SAML metadata, which we need to provide to our IDP. Talking about how IDPs work is way beyond the scope, but I do want to include the configuration guide for it. You'll see here that they give us a couple configuration examples in the SSO config guide, including for, which is, I think, Okta is an IDP that you can use. And then, of course, you can also use Active Directory Federated Services. So in this particular document, it gives us some options, some basic data that we need to include, and basically it's a config guide for how to set up IDP and single sign-on for that. So I'll include the link to that also in case your organization uses an IDP and would like to use single sign-on. Mostly I just want to make you aware that it is an option for administration of the vManage. Okay, so now we've learned about how to do device access with local access with AAA templates and by configuring an IDP using single sign-on. That pretty much wraps up the management plane and the management plane as it pertains to vManage. We'll keep using vManage, of course, throughout the entire video series because that's how we administrate everything. But from a management plane perspective, I think we've covered everything that the vManage does. Join me next time and we'll start talking about the control plane. Hey, thanks for watching.